It is rather challenging to study something we cannot see. One of the traits of a black hole is that once something crosses the event horizon, it cannot escape. Not even light. And because light is so integral in us making observations, that makes it hard, and in some ways, not possible for us to directly study a black hole at this moment in time. This is Cuppa Science Joe, and today I would like to go a little bit over black holes. We will talk about things like how we discovered them, ways in which they can form, and how massive they can get. And you know what? Probably even some other interesting facts as well. Now, black holes are one of the strangest but also most fascinating objects we find in space. They are extremely dense and hold such strong gravitational attraction that, as I stated just a few moments ago, not even light can escape them. Our Milky Way galaxy alone could contain over 100 million black holes, though we can't be certain due to how hard they are to detect. We do know for sure, though, that at the center of the Milky Way galaxy lies a supermassive black hole, which we have named Sagittarius A star. We'll go over this again a little bit later. This mammoth black hole contains about 4 million times the mass of our sun, and is around 26,000 light years away from us, so we at least don't have to worry about getting swallowed up. Before we continue, though, let's turn back the clock to the 1900s. Black holes were first predicted as an exact mathematical solution to Einstein's equations. This black hole solution was discovered by Carl Schwarzschild in 1915. These regions, or black holes, were found to distort space extremely and generate a puncture of sorts in the fabric of space-time. It was unclear at that time, though, if this solution could or would correspond to a real object in the universe. Over time, though, and as other end products of stellar death were detected, such as neutron stars and pulsars, it became clear that black holes were likely real and should exist. Let's use this to turn our attention to the first ever discovered black hole, which was Cygnus X-1, or Cyg X-1 for short. This discovery was made in 1964 when a sounding rocket was launched into space. This rocket carried instruments equipped to detect celestial sources of X-rays. Through this, powerful X-rays were detected coming from the Cygnus constellation. These X-rays would then be further studied by the Uhuru X-ray telescope in 1971. The X-1 in the name tells us that it is also the brightest X-ray source within the Cygnus constellation. Now, we have since discovered where these X-rays come from. Cyg X-1 is a binary system that consists of a blue supergiant star and the black hole itself. We believe that the black hole is steadily siphoning mass from the star. Now, as its material falls toward the black hole, it spirals around it, creating an accretion disk. From what I know, accretion disks actually go this way, but also this way. But when we see it, it's distorted, so it looks like it's going this way. It's the gas and other elements from this interaction that are emitting these X-rays. This picture here depicts what astronomers believe is going on in this binary system. Another thought we might have is, how do black holes form? And to touch on this, we should also cover the different sizes of black holes. These are kind of connected because they don't all form in the same way. And the truth is, we don't know how some of them have formed. But let's touch on the first one on our list, which is stellar mass black holes. Cyg X-1 is an example of this. These are formed from the death of a star. When a star with more than 8 times the mass of our sun runs out of fuel, its core collapses, rebounds, and explodes as a supernova. What's left behind after this depends on the star's mass before the explosion. For these type of black holes, it usually calls for a star around 20 times the mass of our sun up to around 100 times the mass of our sun. In this instance, the collapsed core turns into a stellar mass black hole. Nearly all of this type of black holes were discovered because they are paired with stars, like the example before. And these likely started out as mismatched systems where one of the stars far exceeded the other in mass, meaning it burned through its energy far more quickly. We have found 50 or so suspected or confirmed stellar mass black holes in our Milky Way galaxy alone. Now, what might happen if a stellar mass black hole were to grow? Perhaps swallow extra mass over time is just one such example, or, and we'll touch on this later, merge with another black hole is another such example. And while these are still only guesses on our part, this will bring us to the next size, intermediate mass black holes. These range from around 100 to thousands of times the mass of our sun, and scientists are not really sure how they form. While we are actively hunting for confirmed examples of these black holes, I don't believe we have found any. Numerous candidates have been identified, though, but are just simply difficult to confirm. And this is going to bring us to our third example for today, something we actually talked about earlier, supermassive black holes. These are the ones found at the center of galaxies, such as our Milky Way. These insane objects have from hundreds of thousands to billions of times the sun's mass. Again, as an example, the one located at the center of our galaxy, Sagittarius A star, is 4 million times the mass of the sun. But that is relatively small compared to ones found in other galaxies. To give us a point of comparison, the one located at the center of galaxy Holmberg 15A holds at least 40 billion solar masses. So there's like a really big difference there. Like the intermediate mass black holes, scientists are unsure how these monster objects came to be. Right, like there aren't stars out there in our universe anyway, in our current time, big enough to collapse into something of this gargantuan size. Observation of distant galaxies, though, have taught us that they formed in the first billion or so years after the birth of the universe. Meaning it's possible that they started with the collapse of just supermassive primordial stars that wouldn't really form anymore. Or maybe they simply just had that much time to gather mass from things like smaller black holes or neutron stars. We do also know that when two galaxies collide, such as the long time from now but impending collision of the Milky Way and the Andromeda Galaxy, that their supermassive black holes can end up merging with each other, which would create an even more massive, supermassive black hole. Now, another thing you might wonder about, I know I did, is what would happen if you or I were to fall into a black hole? For this example, we're going to suspend the fact that we would die long before experiencing any of these results, right? Because that is the case. Now, let's say I was the one falling into the black hole and you were an outside observer. You would see me falling towards the black hole, though I would appear to be slowing down the closer I got. As I began to cross the event horizon, however, you would no longer see me moving, nor would you actually see me fall into the black hole. I'd be like a sticker, just stuck there. This is because the light showing that happening itself could never escape the black hole, which means it would never be able to reach you. For me, on the other hand, this is a real term, I would experience what is known as spaghettification. Gotta love that. The force of gravity on my feet would exceed that at my head, causing me to split apart at the waist. This would continue with each piece of me splitting at the halfway mark until I was essentially turned into spaghetti. I have read, though, that if I were to be able to survive that long, I would effectively be able to see the entire history of the universe that had also fallen into the black hole. Something that would be super cool, even if impossible to share with those on the outside. I will say at the end of the day, though, I think it's probably best if we avoid falling into a black hole. And then the last thing I would like to touch on today is what could happen if we follow the math in the opposite direction that led us to black holes. This, on paper anyway, results in what has been dubbed a white hole, an object that can only expel the mass it has rather than steadily swallow it or mass around it. However, I do feel it is important to state that while this can be done with the math, we have not actually observed anything like this in our universe. So at this moment anyway, they're not confirmed or even seen, and it is possible, maybe even likely, that they do not exist. There's truthfully even more about these awesome objects that I haven't covered today, such as how we now know they will eventually evaporate due to Hawking radiation. But even with what we have gone over so far, I find black holes to be fascinating, because while we know and can confirm they exist, there is still so much we don't know about them, given how hard they are to study. And this is kind of exciting to me, right? Because it's the sort of thing I feel could someday lead to newer and more advanced forms of observing our universe. And you know what? Who knows? Perhaps someday in the future, we will discover a currently unknown means of studying and observing them. I hope you've learned something, and I implore you to step outside tonight and look towards the stars.